Hello students, today the topic regarding the subject power electronics that we will discuss is a brief introduction of BJT, that is bipolar junction transistor. So let's start. It is a three-terminal semiconductor device which can act as conductor or insulator based on the applied input signals. And because of this, BJT can be used as switch in the digital electronics, or it can be used as an amplifier in the analog electronics. Nowadays, field effect transistors are widely used in electronic industries, but BJTs are still used. Based on the doping of these regions, it is known as NPN transistor or PNP transistor. So in case of NPN transistor that we will discuss here, and the symbol of this NPN transistor is shown below. In case of NPN transistor, both emitter and collector are doped with N-type impurities and the base is doped with P-type impurity. On the other hand, in the PNP transistor, both emitter and collector will be doped with P-type impurities and the base will be doped in N-type with N-type impurities. Here, bipolar indicates that both holes and electrons contributes in the flow of current. Look, there is a lot of confusion between the students that what a bipolar and a bidirectional means. They consider both the same, but there is a difference between a bipolar and a bidirectional device. Bipolar means both holes and electrons are contributing towards the flow of current, and bidirectional means that it will conduct from both the directions, from anode to cathode and as well as from cathode to anode. So this is a bipolar device. That means both holes and electrons will contribute to flow of electrons in contribution with the flow of current. Okay, now if we look inside the BJT, there are two PN junctions. There are two PN junctions, that is J1 and J2. One is between the emitter and the base, and the second is between the base and the collector. And it appears if two back-to-back diodes are connected in series, but it won't behave like that, because when we connect two back-to-back diode, then we are assuming that there is no interaction between the diodes. That means these two diodes are operating independently, but in case of BJT, actually there is an interaction between the two regions. So if we connect these two back-to-back diodes like this, then it won't be like a BJT. Now if we talk about the internal construction of the BJT, this emitter side is heavily doped, and the function of the emitter is to supply the electrons, and in fact that is why it is known as the emitter. And in case of base, it is lightly doped, and the doping concentration of the collector is between the emitter and the base. That means collector is moderately doped. That is, collector is moderately doped. Here emitter, that means emitter is heavily doped, base lightly doped, and collector is moderately doped. And if we talk about the width of these, three regions, then the base region is very much narrow as compared to the two regions. We can say that the base region is very thin as compared with these two regions, that is emitter and collector. So in terms of width, the collector region is wider than the two regions, because the job of the collector is to collect the electron which is supplied by the emitter, and in fact that is why it is known as collector. Okay, here the concept of why it is known as collector side, why it is known as emitter side must be cleared. Now, depending on the biasing, the BJT can be operated in three regions, that is the active region, the cutoff region, and the saturation region. So let's discuss the active region first. In case of active region of the operation, the emitter base junction is forward biased and the base collector junction is reverse biased. Okay, the configuration is clearly shown in the figure. Here we can clearly see that the emitter base junction is forward biased because of the polarity of this battery source that we are using, and from this we can see that collector base junction is reverse biased. Okay, so let's say the voltage at the emitter is VE, the voltage at the base is VB, and the voltage at the collector is VC. That to forward bias this base emitter junction, the voltage of base should be greater than VE. The condition that must be fulfilled is that VB should be greater than VE for the operation of this forward bias mode. And similarly, to reverse bias this collector base junction, and similarly to reverse bias this collector base junction, VB should be greater than VC should be greater than VB. And similarly, to reverse bias this collector base junction, the voltage at the collector should be greater than the voltage at the base. That we can say that VC should be greater than VB. That means to operate the BJT in active region, we can say that the collector voltage should be greater than base voltage, and the base voltage should be greater than emitter voltage. That collector voltage should be greater than base voltage, and the base voltage should be greater than collector voltage. This is the condition that must be fulfilled in order to operate this in active region. So once this condition is satisfied, then the BJT will operate in active region. Similarly, in the cutoff region, both base emitter region is reverse bias, and both the emitter base region and the collector base region is reverse biased. So to operate BJT in this region, the emitter voltage that is VE, the emitter voltage should be greater than base voltage, and at the same time the collector voltage should be greater than base voltage. So this is the condition which must be satisfied or obeyed in order to operate BJT in cutoff region, that VE should be greater than VB, and at the same time VC should be greater than VB. Okay, similarly, in case of saturation region, both base emitter region and base collector region are forward biased. That means in this region of operation, the base voltage is greater than emitter voltage. The base voltage is greater than emitter voltage, and at the same time this base voltage is also greater than the collector voltage. So these are the three regions of operation in case of BJT. Apart from that, there is a one more region of operation which is known as reverse active region. In this region of operation, instead of base emitter junction, here the base collector junction is forward biased and the base emitter junction is reverse biased. But in this region of operation, the gain provided by the BJTs is very less, and due to that, this region of operation is usually avoided. Similarly, if we talk about the PNP transistor, in active region, emitter is forward biased and the collector base is reverse biased. And in case of PNP transistor I am discussing here, then in case of active region, VE should be greater than VB and VB, and at the same time VB should be greater than VC if there is a PNP transistor configuration, if we are using a PNP transistor instead of NPN transistor. So we can say that an PNP transistor operates in active region. तो क्या कंडीशन है जो मुझे सेटिस्फाई करनी पड़ेगी? द कंडीशन विच मस्ट बी सेटिस्फाइड इज दैट VE, द emitter voltage should be greater than base voltage and base voltage should be greater than collector voltage. Okay. Similarly, these PNP transistor can be used in different regions. So whenever the BJT is used for the amplification, whenever the BJT is used for the amplification, it is used in this active region. So we can say that in order to operate BJT in amplification mode, it must be operated in active region, and whenever used as a switch, then it is used in the cutoff region or in saturation region. Okay, so let's the next we will discuss its symbol. Okay, here is the symbolical structure, the layered structure and the symbolical structure of a NPN BJT transistor, and similarly for PNP transistor. Okay, this arrow indicates the direction of current during the active region of operation. So in case of NPN transistor, the current will flow from the base towards the emitter. On the other hand, if we see the symbol of PNP transistor, then it is similar to the NPN transistor, but here the direction of the arrow is will get reversed. So now the current will flow from emitter towards the base in case of an PNP transistor. Now, as I said, when the BJT is used for the amplification of the signal, then it is operated at the active region, and there are different ways to configure it. Okay, so the different configurations of BJT that can be used are, the first one is common emitter configuration. Here is the symbol of this, the configuration of this configuration. So in case of common emitter configuration, the emitter terminal is common. The emitter terminal is common between the input and the output side. That means in this configuration, the input signal is applied between the base and the emitter, and the output is measured between the collector and the emitter terminal. Okay. Similarly, in case of common collector configuration, the collector terminal is common. The collector terminal is common. The collector terminal is common between the input and the output side. And likewise, in the common base configuration, the base terminal is common between the input and the output side. So this each configuration has its own advantages and disadvantages that we will discuss in another video. But in short, we can say that BJT can be configured in any of these three configuration. In next video, we will discuss the working of BJT. Thank you.